Well, hello everyone, and a very happy 2019 to all of you. I'd like to start the year with a challenge to all flat earthers. I'm going to be looking at some data I've taken for a location in Argentina, Puerto Deseado. I took this information on the 19th of December last year. As you can see, there are sunrise and sunset data for that location on the Earth. So there's our location, pointed out in the center of that compass. At this time of year, it was just prior to the December solstice. So the Earth was at its almost maximum tilt of 23.5 degrees in relation to the Sun. As you can see from this, the Sun is shining on the Earth from the right-hand side of the screen. The Earth is on its tilt, its axial tilt, with the North Pole up here, South down here. And for our observer here, his North is this way, his South is that way, this is West, and his East. And so from this location, he's going to be looking in this direction, the direction of the green arrow, to see the Sun. Now it doesn't matter where on the planet you are, everyone will look in the same direction, off dead on to the right of the screen, to see the Sun. And it's worth taking just a moment to reiterate exactly why that is, because I still see a lot of confusion around this. If we took the Earth and placed it very close to the Sun like this, then you could see that no matter where you are on the planet, everyone will look in the same direction to see the Sun, or they will see the Sun if they look in the same direction. If we move the Earth further away from the Sun, then again, everybody from the Earth, no matter where you are, will see the Sun if they look in the same direction. And this carries on, it doesn't matter how far you move the Earth away from the Sun, as long as it's visible, then even at the distance that we are, the Sun will be a small disk in the sky, but everyone will look in the same direction in order to see it. So with this in mind, our observer in Argentina is looking directly at the Sun at the point of sunrise. North is a 0-degree bearing, so his observation takes place at around 127 degrees, taken from north. As we can see on the time and date data there, 127 degrees, and that's a southeasterly direction. So let's see how that matches up on the flat Earth. On the flat Earth, the Sun will be around here in this kind of transit at the moment, almost bang on the Tropic of Capricorn. At sunrise, for our observer down here in Argentina, the Sun's going to be over here. Now again, here's our observer, north towards the North Pole. South is a bit of an issue because south is technically everywhere on the flat Earth map, but we've put it opposite to north from his location, as it would be, and then west and east. So we can see that from his location, the Sun is going to be seen rising in a northeasterly direction at around 45 degrees from north. But this poses a problem, because as we've seen, the Sun rises in a southeasterly direction, the direction of the green arrow down here. That's almost a 90-degree difference between what would be expected on the flat Earth and what is actually seen and observed in reality. Let's take a look at sunset. So at sunset, we're looking at the Earth from the opposite side now, the Sun off to the left side of the screen. Here's our observer again. Again, here's the Earth's axial tilt of 23.5 degrees, running up like this. So there's our north, there's our south, and our west and our east. So we can see that from this location, because he's looking this way to see the Sun, he's looking in a southwesterly direction. And if this was done absolutely to scale and the angle is measured out correctly, then you would measure this angle at 233 degrees. As we can see on the time and date data, from that date, the Sun set on a bearing of 233 degrees southwest. But again, let's look at a flat Earth. The opposite is true now. The Sun would be here as it sets, continuing on its circular path, and would be seen in a roughly a 45-degree angle between north and west, or a 315 degree angle from north. However, what we see is a 233 degree angle from north in a southwesterly direction of here. Again, almost a 90 degree difference between what would be expected on a flat Earth and what is actually seen in reality. And just to complete the picture, the only time at which the bearing is correct or matches between a flat Earth and the globe Earth is at noon, or midday, or solar noon, should I say, which was 1 in this case, in this location, because the heading of the sun and the bearing of the sun is 0 degrees north, so the observer is looking north to see the sun. However, I just thought it'd be worth clearing this up because, again, I've seen confusion on how the sun can set on a globe Earth, can rise and set in the southerly sky, but then appear in the northerly sky at midday or at solar noon. So the observer's seen the sun rise, the Earth is rotated now from down here to up here, and our observer is here, again, towards the south of Argentina. So you can see that he would be looking at the sun in this direction, and this line here is his tangent line. This represents his horizon. So in his local horizon, this would be a northerly direction, this would be a southerly direction down towards the South Pole there, or the North Pole up here. And so the sun being over here would be more in the northerly sky than the southerly sky in respect to his horizon, and would be at an angle of 66 degrees above it, as we see on the time and date data up there. So this is my challenge. I'd like any flat earther to explain in clear and simple terms, as I have, how these sunrise and sunset observations can be explained on a flat Earth with a close circling sun. Now, I know some people will just immediately cry perspective or refraction, but there's a caveat here. Any assumptions based on perspective or atmospheric refraction must be backed with verifiable data. It's not good enough just to say it's refraction. You need to be able to model that and say how that atmospheric refraction could possibly account for an almost 90-degree difference between the actual direction of an observer will see the sunset in Argentina and the expected direction on the flat Earth map. Okay, well, thank you for listening. I've apologies for my voice. I'm in the middle of a cold at the moment, so I'm probably a little bit nasally. But please put your comments below. Feel free to like and subscribe, and I will see you next time.